Hello, good afternoon, everybody. I'm Rifny Rahman from Data Analytics UOM, University of Manchester. Thank you so much for this opportunity. Today, I will present my project regarding the adaptive AI for multi-objective sustainable supply chain optimization. The background of my project is because of the complexity of the supply chain. It involves the uncertainties. It is related to the demand fluctuation, for example, and also the transportation. So basically, the supply chain is the process to deliver the product from the farm to the manufacturing, to the warehouses, and so on until they reach the market. And it includes large dimensionality because it has multiple hierarchy, for example, and then it also involves multiple facilities and delivery routes. And sometimes along the process, there are also disruptions, for example, production delay, or simply natural phenomenon like storm, heavy rain, because sometimes we want to deliver the product via ocean and there will be storm, and it will result in delays as well. And due to that, there will be risk. For example, there is demand loss. For example, if we deliver the product too late to the market, there will be demand loss, and the product may be defective as well. And then recently there is a concern regarding the sustainable supply chain that makes it multi-objective. So except for the concern about the cost, we will also cover the other facets of sustainability, including environment and social as well. And the economic facet in here is represented by the profit, and the environment will be represented by a greenhouse gas emission. And for the social aspect, there will be delivery fairness. So we are trying to find the trade-off between three of them. And of course, we will also consider the disruption along the process, including the operational, weather, and the policy causes. So the challenge in here is to balance between the multi-objective. For example, we want to balance between the fairness and the profit. Just imagine if we want to increase the profit, probably we will prioritize the customer that will give us more profit with the lowest transportation costs. But we want our delivery to be fair, so all of our customer will be satisfied. Even though it will probably a little bit decrease the profit. And the same thing happens also to when we are trying to balance between emission and profit. For example, just imagine if we want to improve the profit by boosting the production, for example, it will also result in higher emission, but we don't want that. So we try to balance between the profit that we will get and the emission we don't want to produce a lot of emission. So this is the example from balancing between two objectives. So we are trying to generate the Pareto front, which is the set of undominated solutions. And this is the example of Pareto front if we are incorporating three objectives. So we will also give the opportunity to the users to set their preference. For example, one user one user is more concerned about the cost, and the other user probably more concerned about the environment, for example. So they can put the preference in the aspect that they are concerned more in this Pareto front. So this is the network that I'm adopting in my project. In this project, I'm using reinforcement learning in the multi-objective supply chain. So basically, reinforcement learning is one branch of machine learning. So this is how it works. Basically, the AI agent will define the action based on the state, and the environment will receive the action and will give back the reward, and it also will define the next state. And it is like iterating. So based on the reward and the state given by environment, the agent will define the next action, and it keeps iterating along the time step. So to put it simply, our rewards is to maximize the revenue, and the profit, and to minimize the emission and to maximize the delivery fairness. But since these objectives are conflicting one to another, so we need to find the trade-off. And the observation that from the state will include inventory level, outstanding order, demand, cumulative emission, and average fairness. And then the agent will define the delivery quantity and manufacturing quantity that that satisfy the objectives. So why did I choose this reinforcement learning method? Firstly, because of its robustness. Um, um, so it can adapt in customable environment, and then it can search the optimum policy based on the learning. And it's also good for generalization because supply chain networks sometimes could be extended to be very complex networks. So using this reinforcement learning, the learning of the agent will be adapted. And then it has the nature of sequential decision making, which is suitable with supply chain nature. And there is also multi-objective reinforcement learning that is able to find the trade-off between more than one objectives. And then reinforcement learning is also able to learn under the complex dynamic, and it has also good adaptability, and it can also work in continuous action space.